Hi students, I finally got a chance to do a video. I'm sorry it's kind of late. I was in a Camp Buck meeting with the other teachers, so we just got done. I'm not going to do number 5 with you. Remember we discussed that we don't need to do number 6. Remember what kind of shape number 5 is? It's a kite. And remember we discussed in class today that that we were moving the kite to the same formula that we use the parallelograms with, which is base times height. So remember that when you are doing the kite. Again, I would say this is the base because it's kind of going up and down now. So this would be your base, and your height would be from here to here. This would be your height. Okay, so the base is the longer line, the height is the shorter line. They should make a 90-degree angle and then work it out. Looking at A, Number 1, all they want you to do is list the factors and then determine the greatest common factor. So we're not going to do the factor tree with this. We're just going to list our factors. So if I'm talking about 25, what are all the things that equal 25? We know we have 1 times 25 and 5 times 5. For 45, we have 1 times 45. 3 times 15, because I remember sneaky 3. 4, you just add your digits. 4 plus 5 equals 9. So I know that 3 can go into 9, so 3 must be able to go into 45. And then we know 5 times 9. So then at this point, we want to maybe circle our common factors between the two. So 1 and 5 and 5. Now, out of those common factors, so we're going to call those CF, there are 1 and 5. Now, what would be, what would be the greatest common factor with those common factors, which is just 5. So that's all you're supposed to do with this section. Now, let's go to the back side, where we have part B. Now they want you to do some prime factorization like we practiced. It looks like a tree. And then you're going to determine the greatest common factor. So I did 18, and it would look like this. 18, if we did a tree. What are two factors that equal 18? You can pick your any two. So I'm going to say 2 times 9. And then you look at those two factors and you say which one of these are prime. Remember we talked about this in class. A prime number, if we write it like this, I'm writing the word prime. I used to tell my kids to write this, and it would kind of tell us what a prime number is. It's the only thing that equals it is 1 and me. So an example would be like 7. The only factors that equal 7 is 1 and 7. Another example would be 5. The only factors of 5 would be 1 and 5. So once we do our factor tree and we come across a factor that's prime, we circle it. So 9 can be broken down even more, which would be 3 times 3. Are any of those numbers prime? Yes, both of them. So now at this point, we would need to list our our prime factors. And you only need to list, if you have like a double, like we have those 2 3s, you only need to list it one time. So we say 2 and 3, and I kind of box them. Now I do my next number, which would be 42. So let me kind of move over here. Let's do 42. So if we have 40, I'm going to move over here and do 42. So we have 42. We're going to do 6 times 7. 7 is a prime number, so I'm going to circle that one. We're done with him. And then we have 2 and 3. We're going to circle the 2 and the 3 because they're prime numbers. Now I'm going to list them. We have 2, 3, and 7. Now, which ones are common between the 18 and the 42 that are prime factors? So I'm going to do that in a different color so you can kind of see that. We have 2 here and 2 here. We have 3 here and 3 here. So right now I know that my common factors are 2 and 3, and this is kind of a neat trick. You can also, if you have two common factors, you can multiply them. What's 2 times 3? Which is 6. 6 is also going to be a common factor, and we got that from our tree. We were able to take those two numbers, 2 and 3 that were common, and multiply them to get another common factor. Now they ask you to list the greatest common factor out of those common factors. So we have G, C, F, and the greatest one would be 6. So there we go. If you look at C, it says rewrite each numeric expression using distributive property. That distributive property is coming back, but they want you to pull out in the distributive property, the one that you're distributing out has to be a greatest common factor. So you can also do the prime factorization with each number and then do the distributive property. But I can look at 56 and I know, well, I know that 7 goes into 56 and I know that 7 goes into 35. So I know I can pull out 7, okay, because 7 goes into both of them. It would be a common factor. That's why we're working on common factors. So then at this point I say, well, what would I have multiplied that 7 by to give me that 56? Well, 7 times 8 gives me that 56. Now, what would I have multiplied to get that, or to have that 7 go into 35? Well, 7 times 5. And now we've done some distributive property. At this point, you want to finish it out, and you want to actually say 7 times 8 equals that 56, and 7 times 5 equals that 35. And now we're done. So for each of them, you will try to pull out the greatest common factor that they share, and that should be on the outside of the parentheses. And then the other factors would go on the inside. That would equal those numbers I just underlined. So I hope this video helps you. I also left the message and remind that I added a new button to my website, and it's called Notebook Practice Pages. And you can look at those and see the 3 pages that we did in class together with my notes, and that might help you as well. So we'll see you on Thursday. I hope you have a terrific Thursday tomorrow, and I hope you don't have a weird Wednesday tonight with your homework. So anyway, have a good night. See you tomorrow. Bye-bye.